Let's look at lesson 58, talking about tangents and circles. If you remember what a tangent is, we talked about this a few lessons ago. A tangent is a line exterior to the circle, but it intersects at one endpoint of the circle, and if it intersects with a radius, it creates a perpendicular line, but that is if this is a radius. Or the converse of that, if you have a radius, and it is perpendicular to the exterior line, then you know it is a tangent. So therefore we could say line EF is perpendicular with line DG. So now let's use what we know about tangents in some example problems. In example 1, B, it says if the measure of angle CQP is 36, determine the measure of angle PCQ. So look at what it gives us. CQP is 36, so CQP is 36 degrees. Now from here, it wants us to determine PCQ. Well, there's no angle there right now. What we can do is simply draw an imaginary line and create our own triangle. Now, it actually tells us that line N is tangent to circle C at point P. So therefore, since this is a tangent and we just drew a radius, I know that radius is not in the center, but ignore that. But this is a radius, therefore this is a perpendicular line. So since that's perpendicular, if I redrew my triangle, it would look something like that. And I know my dimensions and my drawings are just off today. But anyways, so we would need to find this angle to find, and that would be PCQ. So we do triangle sum theorem, or just note that these two angles are complementary. So 90 minus 36 is what, 54? Yeah, 54. So it equals 54 degrees, and that's how you would use some tangent lines in your circles. Let's look at a couple more, or let's look at another concept. Theorem 58.3 says if two tangent segments are drawn to a circle, okay, so we have two tangent segments drawn from a circle and meet at the same exterior point, then they are congruent. So we have this quadrilateral, it's in and out of the circle. We have two tangent lines, meet at the same point, therefore line NQ is congruent to line MQ. Those are congruent. So in example 4, it says to find the perimeter of this quadrilateral here. So how can we find the perimeter? Using what we just found out, we know that opposite tangents that intersect at the same exterior point are congruent. So this is also 17. Do we know what LK is? Well, once again, my circle dimensions have been off, but L is actually the center, and this is a radius. So LK is another radius. It goes from a center to an endpoint. So now we know all the sides of the quadrilateral. We add them all together, and we would get 50 inches for our perimeter. And so that's an example of how you would use Theorem 58.3. Looking at our last example here, example 5. I like this example. It's kind of a word problem, but I just drew it out. But it says an ornamental window, and once again, my drawings are way off on this lesson. But anyways, it says an ornamental window has several glass panes oriented to look like an eye. The radius of the eye's iris is 3 feet. So I drew the radius is 3. Then it says, and DC, forgot to C right here, DC is 5 feet. What are AI, right here, we need to find, and AH? okay? Well, just at first glance, I noticed that AI and AH, they are actually perpendicular, so they're tangent and they meet at the same exterior point. So we know that these two are actually going to be the same. So therefore we only need to solve for, one thing here. So now how can we figure those out? Well, it gives us 3 as a radius. So all these are radius, their radius is 3. But that still doesn't help us get from A to I or A to H. So once again, you just got to get good at realizing when you can create triangles. So what I'm going to do, I'm going to create a triangle here, and I'll redraw it so you can see it better. And let's see what we know about this triangle. We know that this angle is a right angle. We know this side is 3 because of the radius. However, we're trying to find AH, but do we know AF? Well, if we look at what it's given us, it gave us this 5 for a reason. You always got to look at what it gives you and figure out the reason that it gave you that information. 5 is the distance from C to A. Well, or sorry, C to D. C to D is the same distance from F to A. So 5 is the distance of your hypotenuse. So now we can solve for AH. So you can do Pythagorean theorem. If you know this is a triple, Pythagorean triple, you might be able to solve quickly. But I'm going to go ahead and solve it. 3 squared plus AH squared equals 5 squared. 3 squared is 9, 5 squared 25. Bring down the AH squared. Subtract 9. We get 16 equals AH squared. And to get rid of the squared, we square root. And now we get AH equals 4. And once again, since we know AH is 4, we know AI is also 4. So that's all the solving we have to do there. So that is how you do lesson 58. Y'all make sure to look at my YouTube channel, subscribe to my videos, Stuart B501, follow me on Insta. But y'all make sure to subscribe and keep checking my videos out. Holla.